Maintenant, Anoj Subedi, étudiant à la maîtrise.
Bonjour tout le monde. Today, I'm going to present my internship project that I did with Titre in Rwanda. This project was supervised by Professor Miguel Montero Girona, Professor Flavia, and Emily from CIGEP. The project is entitled as Can Ammoniacal Nitrogen from Gold Mining Effluent be a promising alternative in the fertilization of boreal forest? As you know that Abitibi-Témiscamingue is a very resourceful region with a measure of its economic generated from the extraction like mining activities and forestry practices. Mining activities flourish in the region, in this region after 20th century, and it's favored by the geological location and geographical structure of the region. However, there are several issues that are related with the mining. This mining generates different kinds of effluent that can be harmful to the environment, harmful to the aquatic forms like rivers and lakes. One of the effluent that is generated from mine is ammoniacal nitrogen. Its presence in the river or in the lake in higher quantity may be deleterious for the aquatic forms. That's why the management of this kind of effluent is very necessary. And different mining companies here in the region have been managing this effluent by trading with the sulfuric acid and with the production of ammonium sulfate. However, they are translocating these kinds of effluent to a location which is kind of like far from this region. So there are several costs associated with the transportation as well as the labor costs. That's why we propose this project to minimize this kind of cost. What we proposed in this context was to use this ammonium sulfate locally in this region to increase the productivity of soil, so that the forestry or the stands in the region can get the nitrogen support that leads to the increment in the wood volume. Recently, the application of biochar has been increasing, and biochar is a plant-derived materials, and plant-derived materials like when the wood residue, wood products are heated in the absence of oxygen or in the lower oxygen, they are transferred to the biochar, and when we apply this to the soil, it acts as a soil amendment, and it has a very good absorptive quality, and it's also good carbon sequester. That's why we aim to use the biochar with this nitrogen fertilization derived from the mining and test whether it can be beneficial for the plant growth or not. So can the mining companies and the forestry companies can be bonded together? Can they share the benefits together? Let's see. To identify this, we aim to evaluate the impact of biochar, nitrogen fertilization, and the fertilization of nitrogen with biochar on the growth of black spruce and jack pine. Secondly, to quantify the influence of ammonium nitrogen, but in the field, to see if it changes or if it increases the growth of black spruce. For this, we developed two experimental settings. The first was in the greenhouse, followed by another in the plantation site. For the greenhouse, we selected 25 species each of black spruce and jack pine. And we provided 5 treatments with 5 replications. So the first one was control with no fertilization. Second was just biochar, followed by the medium dose of nitrogen, that is 200 kilogram nitrogen per hectare. The fourth was medium dose of nitrogen plus biochar. And last, it was a high dose of nitrogen. Similarly, in the plantation site, we selected a 8-year-old plantation site in the Abitibi-Témiscamingue region, and we designated 3 blocks within the area. And these blocks were separated into 3 experimental plots. So each of these plots received 3 treatments with 3 replications. The first treatment was the control, followed by the medium dose of nitrogen, that is 150 kilogram nitrogen per hectare, and high dose of nitrogen. So for the measurement, we took dendrometric measurements in terms of height and the diameter in both greenhouse and in the plantation site. In the greenhouse, we monitor the growth for 30th week in 2015, whereas in the plantation, we took the measurement of 25 plant black spruce species from 2050 to 2020. And for the greenhouse, we also measure the biomass after the end of the experiment. So to go to the results, here we can see a graph that shows the trend, how the diameter was changed after the application of ammonium nitrogen. So here we can see on the x-axis the week and on the y-axis diameter in millimeters. So the different color represents the different treatment that we applied. Here, those seedlings that receive no nitrogen, the control plots has lower growth trend, whereas those that receive at least some dose of nitrogen has a higher growth. In terms of growth, for black spruce, the high growth was obtained with the application of high nitrogen doses, whereas for the jack pine, it was obtained with the medium dose of nitrogen. This is similar graph, but for the height of black spruce and jack pine, here we see a different trend for black spruce and jack pine. Is the effect of nitrogen on the growth in terms of height was higher for black spruce, but not for jack pine. And we found a significant difference after the 30th week with the addition of nitrogen fertilization in the greenhouse. So for the biomass measurement, here we can see a graph where we can see two small boxes that represents the control plots as well as the biochar only plot. And the three difference that receive some dose of nitrogen has a higher biomass at the end of the experiments. Here we can see at least almost double of the biomass gain compared to the control plots. And for the experiments in the plantation site, here we can see the trend of diameter growth as well as the height growth with the addition of nitrogen as well as for that with the control. The different points here represent the variability in our measurement, and the x-axis is years, whereas in y-axis for the first graph we can find the diameter, and for the second it's of height. So at the end of the experiment, we found the increment in diameter by 0.96 centimeter and 0.7 centimeter for each year with the addition of medium dose of nitrogen and the high dose of nitrogen respectively. And to come with the discussion for each of the growth in greenhouse, here we can see the increment in growth after the addition of nitrogen compared to those that receive no nitrogen. So we can see the effect of nitrogen that was derived from the mining effluent has very good and significant effect to increase the growth of seedlings in greenhouse. The increment in diameter, height, and biomass can be attributed to the addition of nitrogen that increase the nitrogen loading in the plants. That can be related to the biomass growth for the seedlings in greenhouse. Similarly, for the species of black spruce in field, we saw the increment in growth in a similar pattern as it was observed in the greenhouse experiments. These kinds of increment in growth in the natural stance in boreal forest shows that the boreal forest is nitrogen really limited. We obtain approximately 37% of volumetric growth in the plants of the boreal forest, which shows that, and this 37% volumetric increment was observed with the medium dose of nitrogen. So we found more effect of medium dose of nitrogen than with the high dose. And this signifies that high dose of nitrogen sometimes causes the acidification in the soil. That could be the reason that limited the growth of plants with the addition of high dose of nitrogen. So the last message to the end of the day is that the growth and biomass of the plants can be increased with the addition of nitrogen fertilization that can be with biochar or without the combination of biochar. even with the medium dose of nitrogen, higher growth can be obtained both in the greenhouse as well as in the plantation site. Thus, the ammoniacal effluent can be transformed to the ammoniacal nitrogen, and that can be used as a fertilizers to increase the growth in the both in the greenhouse and in the plantation site. So it can be a promising alternative both for the mining companies as well as for the forestry companies. So it's a win-win situation for both of them. So they can be bonded together for the sake of benefits. And with this conclusion and recommendation, we have submitted this article in the Journal of Forestry Research. And all thanks to my Professor Miguel Montero Girona, Professor Flavia, and Emily Robert from CDEP. And thanks to all the collaborators and partners and funding bodies for this project. And merci beaucoup pour votre attention.
Merci beaucoup, Anoj.